All right, let's take a look at leaving the unit circle with the 6 trig functions. What we mean by leaving is we mean we're not just doing things on the unit circle anymore. We're doing things on triangles, whether they're coordinates, ordered pairs, or if they're just triangles drawn. You had your first example of this on the homework on that number 16, where you're supposed to find the 6 trig functions and the values based on giving an angle theta and then the opposite being 7, the adjacent being 9. Well, by Pythagorean theorem, we would know then that a squared plus b squared equals c squared, and we could pretty quickly calculate that this is the square root of 130. If that's the square root of 130, sine is opposite over hypotenuse, so then I end up getting 7 over square root of 130, and I have to rationalize that by multiplying by square root of 130 over the square root of 130, and I end up getting 7 square roots of 130 over 130 as my sign for that function. And then we're going to just continue to go through stuff like that. Cosine is obviously adjacent over hypotenuse, so we're going to end up having to do the same thing. You'll get 9 times the square root of 130 over 130. After you do that, tangent is actually easier because it's opposite over adjacent, and you end up getting 7/9. Cotangent is that flipped over, 9 over 7. Then these other ones I have to flip them over. But the idea is if I take this original thing and flip it over, I'd get the square root of 130 over 7. And then secant would be square root of 130 over 9. And that's basically what we're looking for there as we go through these. So if you can figure out one, you can figure out all 6. Another type of problem that you're going to be faced with is, what if it's just a generic thing that says find the 6 trig functions for if I have a point 5 comma negative 12. If I have the point 5 negative 12, what you do with that is you go to a piece of graph paper and you say, okay, I'm going to find 5 negative 12. Over 5, down 12 would be right here. And then what you do is you make an angle formed that is perpendicular to the x-axis, like we've been doing with the unit circle, and we figure this one out. So this would be 5, this would be 12. Yes, I'm going in a negative position. That's the locator for that point. And then I just go through and I solve that. Now, a squared plus b squared equals c squared tells us that the hypotenuse is 13. And then we go through and do the same thing. You figure all 6 trig functions based on those numbers then, with this being your angle. Okay, your angle theta is always from the x-axis and then down. And so then you could just do all the opposites over adjacents and all the reciprocal functions and things that we've been doing. You should be able to do that. Then the next group is based on some given constraints. If we have a given constraint or two, well, 2 given constraints in this case, it says sketch a right triangle from the given trig function and find the other 5. I'm telling you that the cosine of whatever that angle is 2/5. Well, what I could do then is say, well, I know that that is adjacent over hypotenuse, so I know this is adjacent, and I know this is hypotenuse. Then I could just say, oh, that's easy. Adjacent is here, hypotenuse is here, and I could make one of those angles, and I could put a 2 there and a 5 there, drop that down, figure this missing side out by doing a squared equals b, this would be c squared minus a squared to get b squared. You'd end up working out 5 squared minus 4 is 21. This would be the square root of 21 or whatever. So then you could figure out this side, and then you could figure out all the trig functions. Well, that would be missing the point that, guess what? The second comment that you were given is that the sign had to be less than 0. If the sign has to be less than 0, that means the sign is negative. This location right there is positive, positive. Well, the cosine is positive and the sine is positive. We would need to flip that thing over. So this is actually a whoops. This is not the correct answer. If I'm given cosine is 2/5 and the sine is negative, then that would actually be the one that's down here. So this would still be 2. This would be 5, my hypotenuse. This would be my angle, because then that's a positive cosine and a negative sine. That's a positive comma negative down in that quadrant. This is telling us that it has to be down there. Then once I get that set up, there's my square root of 21. And now I can go through my 6 trig functions and do my ratios that way. And so you're doing, tangent is sine over cosine. Cotangent, you flip that over. You figure out your sine, you figure out your cosine, and then you flip them over. Okay, that's the basics of doing it. Then when you go through and solve a couple questions like this, you should start to get familiar with what it actually looks like.